We're going to be talking about different approaches to achieving active-active operation and disaster recovery across multiple regions. Now, you probably think it's called getting gory because, we're going to get into gory details. But in fact, we're going to completely gloss over all the details, okay? Because that's hard. Instead, we just wanted to use a horror theme because we're really into Halloween, okay? In fact, we might get into a few details, but we need to leave time for questions at the end. So first off, I just want to quickly baseline on a few terms, concepts, and assumptions. So to start off, while there are kind of different flavors of active-active, Julie's going to be touching on two of them. When we say active-active, we simply mean that there's active data being produced to both regions at the same time, okay? The second thing I want to tie off on is RTO and RPO. If you're here, you probably know what that means, at least to some degree. But just to be clear, it really represents sort of the two key metrics that describe your tolerance for how failure is handled. Generally, they're both measured in time. So RPO is a recovery point objective, and it's about how many seconds or minutes of data you can afford to lose before it impacts your business operations, right, or it becomes unacceptable, right? So for example, if you're in the financial services and you have an application handling financial transactions, oftentimes you have very low RPO or zero RPO, which means no records are going to be lost if there's a regional failure or a failure. RTO, recovery time objective, it's the time in which the application must be restored after a failure. So in simple terms, and I'm going to get gory in a second, if you want to achieve RPO 0, that generally means that the data must be replicated synchronously, i.e. the producer of the data has to get confirmation that the data has been durably persisted wherever you're going to be failing over to. Now, another way to go about doing it, it's the same thing, is of course you could use a dual write pattern, but we need a lot more alcohol to get into that. So we're not going to be covering it in the session, but it's also something that we've seen out there in the wild. Now, point to make is that this doesn't necessarily have to be another region, right? So that happens to be what we're focused on today, but from a disaster recovery plan, it could simply mean another availability zone or another rack in a data center, okay? That has to be defined in the plan. An RTO of 0 would mean that failover is seamless, which means everything has to be automated. Of course, in practice, we know there is really no RTO 0. It's like as close as you can get to 0 because it's a question of physics and how long it takes for light to travel. Now, gory detail. RPO and RTO, not really as simple as I just described. If they're done right, they're part of a plan that has an SLO or an SLA, and there's boundaries and context that's defined in your plan. And in this case, RPO and RTO can actually interact with each other. So what are you talking about, Will? That doesn't seem important. But actually it is, because as mentioned, RTO and RPO is really what's acceptable from a business perspective. So I'll give you an example. And actually, it came up again yesterday when I was talking to another retailer. But the one I'm thinking of, they had a 15-minute RTO for accepting orders, okay? They had a 24-hour RTO for the end-to-end fulfillment process, from when the order was taken to when it was fulfilled. But the RPO was 0. So effectively, they always wanted to take orders. They never wanted to lose any, but they were okay if it took an extra 24 hours to fulfill it. Now, in this case, actually, asynchronous replication was actually great for them, right? Because there's a lot of advantages to it. And their DR process actually accommodated handling unreplicated data when they failed back, right? So provided like the data center, the region wasn't destroyed, the data is still there, it just didn't get replicated over for the failover. Julie's gonna be talking about that in one of the patterns. Okay, so now that we have those baseline concepts out of the way, I'm now going to try to convince as many of you to leave this room as possible. And the reason why I say that is because I think Julie and I sort of independently discovered this is oftentimes we're talking to customers and their belief that they need active-active operation in multi-region disaster recovery sometimes is based upon assumptions that might not be true, okay? So what do I mean by that? Well, first of all, let me start with multi-region disaster recovery. So keep this in mind. Most cloud regions, of course, have 3 availability zones that are isolated. Any given availability zone is oftentimes multiple data centers that have isolation. And so if you have a cloud native, fully managed a data streaming offering like Confluent Cloud, for instance, you can achieve like a 4 nines SLA uptime, okay, and have RPO 0 RTO in that region, okay? So sometimes I talk to a customer and like, whoa, you mean we get a 4 nines SLA just within one region? I was like, yeah. Now, let's examine the motivation for active-active. There's really sort of 2 reasons why you would specifically desire active-active in your DR setup. The first reason is you're investing time and resources in setting up warm DR infrastructure, and in a happy state, you don't want that to be dead weight, right? Just consuming money. So you want to send some of the workloads there. Reason 2 is that you need data locality, okay? That tends to boil down to latency or cost efficiency. Now, some examples where latency matters, things like payment processing, snappy user experiences, gaming, smart city. Location clearly matters immensely with these sorts of scenarios. And data locality helps with costs because what it can do is reduce the number of times data has to traverse the network, right? So if you're doing lots and lots of reads, then that's another reason why you want data locality. So I guess the gory detail here is just make sure that you validated your reasons for active-active and multi-region disaster recovery. Make sure that the cost of implementing active-active doesn't actually outweigh the cost benefits of using an active-active setup. And you'll get a feel for what that looks like when we get into the patterns. Okay, so if you're still here, I didn't convince any of you to leave. Maybe it's my magnetic personality, or maybe it's no, she doesn't think so. Okay. So if you want to do multi-region, there's generally 2 approaches that you can take, okay? Now, most of you are probably aware, and I kind of alluded to this when I was challenging the need for multi-region, but if you have a single Kafka cluster, replication and failover is essentially built in, right? So clients fail over automatically if there's a broker failure, and your applications can ensure synchronous replication across brokers by using the correct configuration, okay? So by leveraging this, you can actually get multi-region DR with using a stretch cluster effectively, okay? And for instance, Confluent offers some additional capabilities specifically for multi-region. If you're using our self-managed product, we refer to that as MRC. And we have plenty of customers doing this, but it's like no walk in the park to set up and operationalize. There's no fully managed offering of stretch clusters across regions. And we're not really going to go into any more details around stretch clusters, but again, happy to answer some of those questions, talk about it in more depth after the talk. Just grab us. The second approach to multi-region DR can really be bucketed into a category I would call inter-cluster replication solutions, okay? So these are all technologies that are focused on replicating data from distinct clusters, and currently all of them are asynchronous, okay? So examples of technologies here, things like Mirror Maker and Confluent Replicator and cluster linking. And this is really what we're focused on today. And I would say all the patterns that we're going to be covering more or less can be achieved using any of these. There's different wrinkles, there's different gory details, but it's achievable with any of them, okay? I think specifically cluster linking is what we're focused on just because it's fully managed and it's probably the most advanced, not probably, it is, the most advanced technology for achieving this. Okay. So there's lots of advantages actually to using inter-cluster replication over stretch in MRC clusters. I'm not going to go over all these. I am going to hit on 3 of them. So the first one is that when you're doing stretch clusters, the generally maximum recommended latency between clusters is 50 milliseconds. So right off the bat, with inter-cluster replication, you can support much greater distances and latencies than you would with a stretch cluster. It also allows for more sophisticated topologies, right? I mean, yes, you may just have 2 regions, so for failover, but you may have aggregate, you may have fan-out topologies that you can also do disaster recovery in. And I think the last one, skipping to the end, is that operating a cluster in a single region is much simpler, it's less error-prone, and it enables one to leverage cloud-native primitives that only exist within the region that the underlying CSPs provide. As soon as you start stretching clusters over multiple regions, then there's cost implications, there's management implications, et cetera. So with that, I'm going to hand it over to the obvious brains of the operation to go into the patterns.
Yeah, thanks, Will. All right, so as Will just mentioned, it's how your applications are deployed that's actually going to determine which pattern you end up using. So I'm going to go over 3 different ways you might want to deploy your applications and the pattern I recommend for each, and then we'll get into all those gory details. Okay. So first up, the first way you might want to go about deploying your applications is you might want to have 2 totally unique sets of applications in each region. Now, in this scenario, even though you are running an active-active deployment, your applications themselves are not active-active. You're really just trying to maximize your infrastructure investment here, as Will mentioned before. I typically see this when, companies have multiple departments and they each have their own Kafka infrastructure, but they want to start leveraging what the other team has. So if this is how you want to go about deploying your applications, I recommend you use what we like to call the independent data pattern. And this is probably the most common pattern that I see my customers use. And the reason for that is because it's the easiest to evolve into. Most customers actually start with an active-passive pattern, and then as they grow their Kafka usage, as they start deploying more applications, they want to leverage that passive region, and so they end up deploying applications there, and it looks like this. And you can kind of see how that can happen, right? Like if you take away apples or you take away oranges, it's just an active-passive deployment. So because of that, I'm actually not going to go into this pattern today. Instead, I'm going to route you to the white paper that's in that QR code. This goes over exactly how to do failover and failback for an active passive. You're really just sticking those 2 together, going in both directions. All right, so the next way you might want to deploy your applications is maybe you do have the same applications in both regions, and you're doing this to have those low latency writes for some cost efficiency, but the applications in the region really only care about what's happening in that region. So once again here, we're still going to recommend the independent data pattern, and the reason for that is because since your applications only care about what's happening in the region that are local to it, still 2 active-passive patterns stuck together, so you can still use that white paper. Now, the third way, which luckily is not in the white paper, so we'll actually have something to talk about, is if you want to have the same application deployed in both regions, again, to get that low latency read and write, but you also want to have your consumers eventually consistent with the global data set, then you're going to want to run an application diagram that looks like this and use what we like to call as the cumulative data pattern. And you guys, she has it all. She has all the gory details we could ever want. So I am actually going to walk us through from a high level how you fail over and fail back. We're going to get into all the gory details. For all you independent data pattern users out there, these gory details still apply, some more than others, depending on how you choose to deploy. So let's get into it. Okay. So the first gory detail you're going to have, which you maybe already noticed, is that you now have split topics, right? Because you have one topic that has all the local data and one topic that has the remote data. And this occurs because of how the replication tools work. So all three of those tools, they're going to create a new topic in the destination cluster that contains all the data being replicated from the origin. So, even though you have split topics, it's not necessarily a bad thing. It just adds some complexity to your architecture.
I mean, actually, personally, I think it's ultimately simplifying because, Confluent Replicator, we didn't talk about it, but can support a single topic. But the ability to logically partition the data, I think, is ultimately as simplifying as you fail over and fail back. So
absolutely. It's definitely helpful to know where the data came from going forward and for future use cases. So because you have split topics, the next kind of gory detail we have is that you need to add a prefix to your topic names. Because as most of you know, you can't have two topics with the same name in the same cluster. Now, this is really important because how you add the prefix is actually going to have some implications. So there's two ways you can add a prefix when you're creating a topic. So the first way, of course, is your application can do this when it's creating the topic. That's what we see in this diagram here. And here you can see, like in region A, the Apple producer created a.topics, and our replication tool has maintained that name as it creates it in the destination cluster. Same going the other way for region B. Which is really great. It's nice to have very clear which region is coming from where. The other option you have is you can actually add the prefix using the replication tool. So I just updated it. You can see we now have an Apple's topic in both regions, and the replication tool has appended the prefix. Now, this is really important, and actually there are some advantages to adding the prefix via the application that come into play during failover. So I'm going to put a pin in this for now, but we're going to come back to topic prefixing. For now, just know you need to do this, and you need to really think about which option you're going to go with. All right, we're still in steady state. How is that possible? But there's one last gory detail for steady state, which is message ordering. And I have to say, this is probably Will and Mai's favorite gory detail. We've definitely spent the most time talking about this one.
no blood was spilled.
No blood was spilled, but definitely some healthy debates. So when you have split topics, you now have two topics containing all your data. So you really need to think about how your messages are in order, because you now have to think about it from two different levels. You still need to think about it from within a single topic and how that topic gets replicated to the other cluster. But you also need to think about it from the consumer now, because the consumer is reading from two topics to get all of its data. So first, for keeping the topic in order itself, we of course use our lovely message keys for that. But you're going to want to make sure your replication tool is maintaining that ordering when it creates it in the other region. So all the replication tools can help you with this. Cluster linking does it automatically. Confluent Replicator and Mirror Maker 2 just need to be configured to do so. So just make sure you do that. Where it gets really fun, really tricky, is when it comes to those consumers. Because you cannot guarantee that you are going to read the messages in any order from the consumer. Like Kafka doesn't allow you to pick which topic you read from first. But if you logically partition your keys in a certain way via your producer, you can have ordered messages. So let's get into what we mean by this. Let's take a break from apples. Let's move to chess. Let's say Will and I, we have an online chess game. Obviously, the sequence of moves matters in a game, not only to make sure it's played appropriately, but players like to see that during and after the game. Now, to keep our messages in order, we will use the player ID as the message key. Now, Will and I have noticed that for our players, while they play a game, they're pretty much always in the same region, right? Like if player one is in region A, they never really move. They're playing at home, they're playing at work, they're playing on their bus ride home from work. So all their moves really just go to a.chessmoves. And we're using a key, so a.chessmoves has the messages in order. So when chess consumer is reading from a.chessmoves and b.chessmoves, really it only gets player one's messages from one of those topics. So it's reading those messages in order. Now, I'm sure quite a few of you in the room are like, whoa, well, what if player one moves? Like, what if player one started playing their game in California and region A is for the West Coast and region B is East Coast? What if they flew to Austin, they're bored during this talk, they're playing the game, and now their moves, I know, none of you would do that. But what if all of a sudden their moves start going to region B? Now you're going to have out of order messages, right? And that would be true. But Will and I were crafty. We thought of that. What if we decided, This is chess. It doesn't really matter if there's some extra latency. It doesn't impact the game. It doesn't impact the user experience. So we're going to bound our users to the region they started playing the game in for the duration of the game. We're going to make sure that player one is always writing to region A while they play, which means they always write to A.chess moves, which means the consumer is always going to read player one's messages in order. Now, this, of course, only works if you can do this, right? It sounds like a very niche use case, but this comes up more than you would think for Will and I. Yeah. So as a rule of thumb, just know your consumers can't guarantee the message ordering if they can't make sure that they can either handle out-of-order messages or sort them themselves.
Yeah, I think the bottom line is you either have to maintain the ordering by partition at the producer layer, or you got to sort it out after the fact in the consumer, which can be kind of tricky.
Yeah, absolutely. All right, I think I'm ready to actually see some failure now, so let's move on. We're done with the steady state. So a failure has finally struck, and you now need to act. So the first thing that you're going to want to do is you're going to want to move your applications to run in the healthy region. So part of doing this means you need to update any application that is communicating with the Kafka cluster in that impacted region to have the healthy cluster's bootstrap and security information. The problem with this is the only way those configuration changes get persisted is if you restart those clients. This is by far the #1 complaint I get when I go over DR. Not everyone loves this. I think Will has seen the same.
Yeah, I mean, I kind of think it's a knee-jerk reaction because the reality is this is almost always part of a process which includes many applications that has to be orchestrated. So like restarting an application, fetching the information from Vault or something like that, not a big deal.
Yeah. So keep in mind this restart absolutely impacts your RTO. It's probably going to be the biggest part of your RTO, aside from noticing that there's a failure. So definitely factor that in when you're setting up those requirements. Now, a little silver lining here is that, as Will kind of alluded to, you can automate how these configurations get updated. Once again, a shameless plug for that active passive white paper because that is all detailed in there. So if you want to see how to do that, that is a good spot, even if you're doing cumulative data pattern. All right, let's get the party going though. So we are now back to topic prefixing. I know you were all on the edge of your seat waiting for it. So when you move your clients, you really got to think about what happens when they're now running in that other region. Because usually, no one updates the topics, like the list of topics that the producers and consumers are working with. So you want to make sure they're working with the topics you want them to. So let's go back to our 2 ways you can add a prefix. The first way, which was the way has a little bit more of an advantage, is you can, of course, add a prefix via the application. Again, that's what you're seeing in this diagram here. Here, when Apple Producer in region A was in region A and actively running, it wrote to A.apples. But when it moves to region B, it's going to continue to want to write to A.apples. This is good because A.apples exists there. Especially if you care about message ordering, this is important because A.apples in region B is effectively the same topic as in region A. So you'll maintain your message ordering there. This, however, is not the case if you prefixed via the replication tool, because when Apple Producer in region A was writing, it was writing to apples in region A. But now when it moves to region B, it's writing to region B's apples, and that is not the same topic. A.apples is. Now, it's not always a bad thing that this happens. Sometimes this is actually really convenient and nice. You just really got to think about how you want your producers to act and make sure they're actually going to be reading and writing from the topics that you think they're going to be reading and writing from. Now, another really fun twist here is that your replication tool actually matters in this discussion. So, for example, cluster linking creates read-only mirror topics in the destination cluster. So sometimes you want to leave that as a read-only mirror topic. There are advantages to doing that. Other times you maybe want to promote it to be a writable topic. So again, just think all of that through before really deciding how you prefix to make sure it goes the way you want. Now, I wish I had time to go into every replication tool and prefix and kind of that matrix, but we just didn't have time to fit it in. So that's another thing that if you want to talk about after this, definitely ask Will and I.
Honestly, I'm just going to say, I'm going to put a plug. Just do it at the application tier. This is the thing with I'm just always prefix at the application tier. You may have an argument otherwise, but I just think it's simplifying and it solves the whole ordering thing when you fail over.
Yeah, it's definitely more clear when you have the prefix in the name all the time. Alrighty, we keep on trucking, you guys. So at this point, it is time to take a moment of silence for all of the data we have lost. We have asynchronous replication tools
But
here.
have we really lost it?
Well, don't get ahead of us.
Okay,
Oh my
okay.
God, Will. He already knows the ending of this presentation. Anyway, we keep moving. So these are asynchronous replication tools. There is always a chance you have not replicated all your data, and with any disaster, there's always a chance you're never getting that data back. For most of my customers, this is not a big deal. Of course, if you're in financial services or utilities in any highly regulated industry where there are legal reasons you have to have an RPO of 0, obviously this is not okay. But for most of us, that is not the case. You can tolerate a little bit of data loss. Keep in mind that, obviously no one wants to lose a lot of data. You can definitely tune all of the replication tools to have a minimal replication lag. You can monitor that. So you can get this number down pretty low. Now, as Will mentioned before, your RPO and your RTO do interact. So you absolutely can try and recover that data. Recovering the data is not always possible, but it's certainly usually possible. So it's always worth a try. But we put it as a Gory detail because it definitely takes some extra effort. Now, exactly how you do this depends on your replication tool. If you're using Confluent Replicator or a Mirror Maker 2, you'll set up an instance of that tool and then you'll configure it to grab X minutes before the outage happened. The reason you do this is you can't know the exact offset that was last left off on, so you just have to grab a window. Usually my customers do 5 minutes, but you can do longer or shorter depending on how long it takes you to notice that outage. Now, keep in mind when you recover data, you're definitely going to be reading those messages out of order, so make sure your consumers can handle it. And you will be getting duplicates, so also make sure your consumers can handle that. Now, if you're using cluster linking, it works a little bit differently. And again, to keep things brief, I just put the instructions to our docs, so be sure to grab those QR codes. There's actually 2 options, which is nice. All right, you guys, we're almost there. All right, so the impacted region has recovered, and now you're ready to return back to steady state. So the first thing you're going to want to do is you're going to want to catch up the impacted region with all of the data that was produced during the outage. This, again, varies by replication tool. If Will and I were given more time, we could have definitely gone into way more detail here. But each replication tool can definitely be used to replicate that data back. Each of them has their own Gory details. I will say Confluent cluster linking is by far the easiest here. Not only does the cluster link automatically pause when one of the clusters can't be reached, but you can also choose when it restarts that replication. And there are a bunch of commands to automate failover and failback. So you just kind of put in a couple lines and it just takes care of itself.
And APIs, of course.
And the APIs, yeah, can't forget about those lovelies. So take a look at your tool and see what makes most sense, but you just have to replicate that data back. Now, once the region has caught up, you do have to move your applications again, which means you do have to do a restart. This restart is usually a little bit less painful though, because you're in control now. Your hand isn't being forced by a disaster. A lot of my customers choose to do it during a normal maintenance window, or in the middle of the night when they don't have any of their customers online. And that's it, you guys. We did it. With only 5 to 8 Gory details, you have made your way through an active-active scenario. For those of you who will use Confluent Cluster Linking or Confluent Replicator, there are some tutorials that we have on our website that can walk you through some of these patterns. I'm also working with some other folks at Confluent to write an active-active paper that'll contain a lot of the data or information we went over today. I hope you guys didn't think these details were too gory. I find that once you know what they are and you understand them, they're not too hard to tackle, so they're a little bit less scary. Thanks, everyone.
Fantastic. Thank you, everyone.